what if I told you that the speed limit of the universe might not be so final after all? That one day, we might just travel faster than light, bending space, breaking time, and possibly changing everything we know about reality itself? To understand what's at stake, we need to first understand the cosmic rulebook. According to Einstein's theory of relativity, nothing with mass can accelerate to the speed of light, or beyond it. The faster you go, the more energy you need. At light speed, you'd need infinite energy. That's impossible, right? Photons, the particles of light, are massless, so they're allowed to travel at 299,792 kilometers per second, our universal speed limit. But what if we found a loophole? Enter the Alcubierre warp drive. In 1994, physicist Miguel Alcubierre proposed a wild idea. Instead of moving through space faster than light, why not bend space-time around you? Like a surfer riding a wave, you wouldn't be breaking the speed limit, you'd be moving the road beneath you. This theoretical warp bubble would contract space in front of you and expand it behind, allowing faster-than-light effective travel. But there's a catch: it would require negative energy, something we haven't yet found a way to generate or stabilize. Assume we somehow build a warp drive or use hypothetical particles like tachyons, which always move faster than light. Now what? Things get weird. Fast. Causality breaks down. Events can happen before their cause. You might arrive at your destination before you leave. The grandfather paradox becomes real, where traveling back in time could prevent your own birth. Physicists call this a violation of Lorentz invariance, a foundation of modern physics. So even if it's possible, it might break the universe as we know it. So, in Einstein's universe, speed actually affects time. As you approach the speed of light, time slows down for you compared to folks who are, just hanging out at rest. This effect is called time dilation. For astronauts on a ship moving near light speed, hours might tick by for them while years could fly by back on Earth. Now if we somehow manage to go even faster than light, well, some models suggest that time could actually reverse. Theoretically, you could witness stars forming in reverse, watch civilizations disappear, or, wild as it sounds, even meet yourself in the past. But honestly, would your mind or your biology even survive a trip like that? Let's not forget, space is just packed with dust, gas, and, rogue particles. At the speed of light, hitting even a single grain of sand would be, like crashing into a bomb. The kinetic energy would be absolutely catastrophic. We'd need some sort of particle deflector, energy shield, or maybe have to travel in a complete vacuum corridor. And then there's inertia. Our bodies just weren't built to accelerate that fast. Unless we somehow master inertial dampening, the G-forces alone could totally crush us. So it's not only about the technology, it's about whether we could actually survive the ride. Instead of, trying to push past the speed of light, what if we just skip the space between? Wormholes, which are predicted by general relativity, are these theoretical shortcuts through space-time. Imagine space as a folded piece of paper. A wormhole connects 2 points directly, like poking a pencil through that paper. Traversable wormholes are still totally theoretical, but physicists like Kip Thorne, the guy from Interstellar, think they could maybe work under very specific and exotic conditions. And then there's quantum tunneling, where particles jump across barriers instantly. Could that kind of phenomenon ever scale up to, say, spacecraft someday? If faster-than-light travel becomes real, even just for uncrewed probes, everything changes. We could explore distant galaxies in our lifetime, colonize planets, escape existential threats, become an interstellar species. It would also change our culture. Our concept of distance, time, even borders would vanish. Maybe we'd meet other civilizations, maybe we'd become them, but we'd also have to answer some tough questions. Who controls this tech? What rules apply in interstellar space? Are we mature enough as a species to wield it? So how close are we? Today we're still decades, maybe centuries away from viable faster-than-light travel. NASA and others explore ion propulsion, solar sails, and fusion drives, but these are still far slower than light. Theoretical work on warp drives continues, but remains, theoretical. Still, the dream persists. After all, every impossible thing starts as imagination. So maybe it's not about whether we can break the light barrier, but whether we dare to keep reaching. Faster than light travel isn't just about speed, it's about exploration, discovery, hope. It reminds us that we are curious creatures, staring up at the stars, wondering what's out there, and maybe someday, we'll go fast enough to find out. Like, share and subscribe to my channel for more frequent science and tech videos.